Hello, I'm Robert. Welcome to my channel where I fact check the stories that scare you. And this time it's about yet another totally fake NASA asteroid warning. It's not a warning by NASA at all, it's just made up. This is Asteroid 2001 FO32, and it's a very well known, well understood asteroid, and it passes by at a very safe distance and of 2 million kilometers, and that's many times the distance to the moon in March. There's no risk of it hitting us then or for centuries into the future. And they call it a potentially hazardous asteroid. That is indeed what NASA call it. This means, and so astronomers, they think rather differently from most people. They have a longer timescale where they think about things. And for them, potentially hazardous means there's a potential of a hazard sometime in the next 20 million years. A small chance. Most potentially hazardous asteroids don't hit us even in the next 10 million years or 20 million years. Indeed, most of them eventually, after many flybys of planets and eventually they hit the Sun, or they are ejected from the solar system, or they hit Jupiter. Those are the most common destinations of the asteroids that fly past Earth. And there's just a few % chance that they could hit us. And there's a few % chance they could hit Mars or Venus. Because Earth is so absolutely very tiny, and every time it flies past Earth, if it flies past, it's far more likely for a near-Earth asteroid to fly past Earth than to hit it. Every time it flies past Earth, it gets deflected a bit, and eventually it's likely to get deflected within the range of other planets, and then those then deflected again, and eventually it's most likely to hit the Sun or to hit Jupiter or to leave the solar system, because planets are so tiny compared with the vastness of the solar system. And then we get people who just don't understand. They just keep saying, but what if it swerves out of the way? What if it changes direction? Well, this just doesn't happen. And you can get an idea of this from our spacecraft that we send to Mars. We've sent many spacecraft to Mars, and none of them have swerved out of the way in unexpected ways. Indeed, we can and we don't need to do corrections except for our own, if we set it off on a path that was just very slightly off, then we can correct that as we get closer to Mars. If we could send it off a perfect trajectory right away, there would be no corrections needed for the entire journey to Mars. And by the time they've got the data, of course they have more precision because they've got the timing of the signals back, gives them a bit more information. But the idea is essentially the same. With asteroids, we do it by photographing them at different stages along their path. Whereas with the spacecraft, they're too far away to photograph. We use other methods. We use the photographs taken by the spacecraft, and we use the time of the signal back to Earth to guide them. But the path is very, very precise, and we know where they're headed. And by the orbit, we work out the orbit. From the orbit, we know where they're headed, and we can manage to fly past Mars at a very precise distance. But it's very similar with an asteroid. It's the same maths, the same basic maths. The way we get the data and the way we can work out where it is in its orbit is a bit different, but the same maths as to how we decide where we're going to be headed with an asteroid and where a spacecraft is going to be headed. Exactly the same maths. And that is why they can be totally confident that this asteroid is going to pass by at 2 million kilometers and not, say, 100 kilometers or 500 kilometers or hit Earth. They can't do that because we know its orbit very precisely, because we've got so many data points along the orbit of this 2001 FO32, just like we have all those data points along the orbit, the transfer orbit for Perseverance on its journey to Mars. It's exactly the same mass. So you can be confident this maths works. They know where the asteroid is going to fly past. And they've done this for numerous asteroids, and they always get it right if they've got enough data. So 2001 FO32 is absolutely no risk to Earth. And when it flies past, it will be too faint to see with your eyes. Astronomers will be able to follow it with a telescope with a mirror at least 8 inches in diameter. That's not a very big telescope, but it's way beyond your eyes. Your eyes can't match a telescope that's 8 inches in diameter. Your eyes are too small. And there's never been any NASA asteroid warning. I've talked about this one before, so you could click through to the link, and I think have I done a video for that? I've got a video about that, so you could click through and you'll find that. And then this is the NASA Asteroid Watch page, and if there was an asteroid warning, it would be posted there. There never has been. There's never been any NASA asteroid warning. They would have warned about Chelyabinsk, but it came from the direction of the sun and they missed it. They can miss very small asteroids, but they still spot even the smallest ones. They spot half of them in advance nowadays. The smallest ones large enough to harm us in any way at all. So the Chelyabinsk one, it blew out windows over quite a large area, and the people who were hurt were people who rushed to the window, mainly people who rushed to the windows to see what was going on when they saw a bright light, and then there was the sound of the shock wave, and the glass shattered in their face. So if you see a bright light of a fireball going across the sky, don't run to a window. Shield your hands if you're indoors, if it's a very bright fireball, like Chelyabinsk. And because there's going to be the sound of a shock wave, and one teacher actually saved all her school children from injuries. She wasn't well up on asteroids particularly, but she'd had the warnings that these USSR did during the Cold War, and she remembered what you're supposed to do, and so she told them all to get behind the desk when she saw this flash of light. And then when the sonic boom came, then they weren't hurt. She was hurt because she was standing up, giving them instructions, giving her children instructions to crouch behind the desks. Anyway, so your chance of being hurt by even a small asteroid like Chelyabinsk is very, very small. That's just one incident in a century over billions of people. And then the very, very rare occasions when someone has died of an asteroid. 3 reindeer herders were killed by an asteroid in 1908, and there have been a few other incidents like that, a few per century. But compare that with lightning, where 20 die every year in the United States, or compare it with the very rare death from a hailstone, and the last death from a hailstone in the United States was in the year 2000. And the deaths by an asteroid are far less than even those. There's never been a death by an asteroid in the United States. One woman got a very bad bruise to her thigh as a result of being hit by an asteroid. I mean really bad. She had to go to hospital for it. But there's nobody has ever died of an asteroid in the United States in all the history we have. But, so it's a very, very the risk is very low, and we know all the very large ones up to of 10 kilometers or larger, and they can't hit us for centuries, for thousands of years. And of all the ones at 1 kilometer, there's a very remote chance of one of them 4 centuries from now, but it's expected to miss, and we found nearly all of those. And it's not likely that there's one in the remaining ones to be found that could harm us in less than centuries. and we can deflect these things. So I don't know if I've done a talk about Apophis. Maybe I'll do a talk about Apophis in a minute. I don't think I've done that. So, and then this is my graphic to help put this in perspective, that I just said, what if? So what if the Egyptians, so there's almost, you can really forget about the risk from very large asteroids. Comets are very rare these days. So even though there could be times in the past, and there may be times in the future, hundreds of thousands of years in the future, when there are more comets than usual. But the long period comets, I mean, the ones that we find, and then they hit, they can fly through, or they can sometimes they can sometimes very close to the sun and disintegrate in the sun, these comets. But the sun is absolutely huge compared with the Earth. And so these fly by several every year. We get these very long period comets. But the solar system is so huge. Typically they fly past about the same distance as the sun, the nearby comets of the very long ones. And the closest any of those has gone is Lexell's comet, which passed by at about 6 times the distance of the moon in 1770. And then there's never been there's one very small one, a few tens of meters across, that passed by a little bit closer than that, but not much closer. And the moon is a huge distance away. You're talking about I mean, it takes to go all the way around the Earth and back again on the equator in 747 takes a bit short of 2 days, and the moon is 10 times further away than that. No, is about 10 times. Just a second, I'll just double check that. Okay, so this is the simple mass. The circumference of the Earth is 40,000 kilometers, and the distance to the moon is 384,000 kilometers, so it's about 10 times, a bit short of 10 times the distance, circumference of the Earth. The speed of a 747 is about 920 kilometers an hour. I don't know why it says you, but it's hours actually. And the fastest ones are around 900 or so. And so now if you work out the distance to the moon and then you divide it in hours, then divide by 24, it's 17 days of travel away to get to the moon at the speed of a 747. So, and this is 6 times that distance, is the closest that any comet has ever come in history. So back to our diagram. So if the Egyptians, if they develop asteroid detection telescopes, then this wouldn't be a good place for a telescope actually. They would need to be much higher than that, not just on top of a pyramid. I thought it was a nice way to make a kind of graphic to show the idea. And they would still be waiting for the first city killer impact, because there hasn't been any since they built the Great Pyramids. No city has ever been hit by an asteroid. Plenty of cities have had volcanic eruptions, they've had tsunamis, they've had earthquakes, they've had hurricanes, but none of them have been hit by an asteroid. So it's a very rare thing to happen. And the reason is because only 1% of the Earth's surface is urban, and the asteroid impacts the small ones like Chelyabinsk or Tunguska, and they don't affect a large area of the Earth, very small, much smaller than an earthquake or volcanic eruption or hurricane, and they're also much rarer than any of those. One of those maybe every century or so. You're talking about thousands of years on average you'd have to wait before one of them is going to hit a city. Expected time to wait. So that's why I say that the most likely thing so this is the most likely next asteroid impact is going to be a harmless splosh in the ocean. So at some point, because we get these every century or so, and we're getting better and better at detecting them in advance, NASA have predicted a few fireballs just a few days in advance, harmless fireballs. I think 4 so far. and eventually we are going to be hit by another Chelyabinsk, maybe this century, maybe next century, and maybe even a somewhat larger one. Those are the most likely. The smaller they are, the more likely they are. But the most likely place for the next one to hit is in the ocean, because most of the Earth's surface is ocean, and the asteroid doesn't home in on land, and so you get a very dramatic splosh, and it wouldn't cause a tsunami because the splosh wouldn't travel very far, even if it flew up 100 meters, but it wouldn't cause a 100-meter tsunami, because the reason that tsunami can spread so far, it has to be 20 times the depth of the ocean in its wavelength. And that's why it's almost invisible. You can't see it. If you're on a boat on the sea and you're nowhere near the coast, you can't tell that there's a tsunami going past you, because it's only lifted the sea by a few tens of centimeters, but it's spread out over vast wavelength of 100 kilometers or more, and that's why it's able to travel so efficiently over the ocean, and then it bunches up as it gets to the coast. So, it needs to be a really huge asteroid to create something like that, because the wavelength is roughly the size of the asteroid. So if your asteroid is 50 meters across, and that's quite big for a small asteroid, that it gets less and less likely the larger it is, then it's only going to create a splosh about 50 meters in diameter, and the sea is much deeper than that, and that would only create a tsunami kind of effect over something a 20th of that size, of a 50 meters, so about 2.5 meters. So you're not going to get a tsunami from a 50 meter diameter asteroid, even if it's a little bit bigger than that. You're only talking about something a few meters deep that it'll be able to spread efficiently across the ocean. So an asteroid a small asteroid impact create a big splosh, but there's no tsunami effect. So it doesn't, because you can get tsunamis to do with how it travels. You can have a tsunami just 1 meter high, and you get warnings of tsunamis 1 meter high quite often in the Pacific region because of the Great Ring of Fire. If you're off Australia or somewhere in one of the Pacific Islands, you may be used to getting warnings that there's going to be a tsunami 1 meter high. But you can't even get a 1 meter high tsunami from an asteroid because it's just not big enough. You just get this big splosh, and it actually even doesn't splosh away even most of it, because it also not only creates a splosh, but it evaporates away, create a hole in the ocean where it hits. So it creates a hole in the ocean which sucks in the big wave that it creates. So most of the wave just flashes up and it ends up in the hole that the asteroid itself created in the ocean. And then you just get ripples going out from that. You would have to be in a boat. If you were quite close, it would be dangerous. But you have to be pretty close to a splosh in the ocean to be by an asteroid. And this gives an idea of the size of the most likely next impact that's big enough to get through the ocean. You could have a plane. So it would be pretty dramatic if you got a really big one, like 50 meters or something. It'd be pretty dramatic, and you get astronomers flying out to watch it. But even if it was 50 meters in diameter, if it's just going to splosh in the ocean, there's no point in deflecting it. And instead, just have a look at it, and you'll learn about asteroid impacts from noticing what it does. And even if it was 100 meters in diameter, I think they just watch it if it's going to hit in the middle of an ocean, because it's just not going to. And then if you want to deflect it, then you don't have to deflect it away from Earth completely. If it's a small asteroid like that, you can just deflect it away from the nearest coast and the nearest land to the nearest ocean, if it is going to land on land. Because again, it's completely harmless, except maybe for some fish and some unfortunate jellyfish or something. But it's not going to harm us. So So I mean, if you care, you could deflect it and say we need to protect the jellyfishes and the porpoises and things, and then deflect it away from the ocean and away from Earth completely. But that would be the only reason if it's going to land in the middle of an ocean. So that's most likely next prediction is landing in the ocean. And so you can visit these pages, but really there's no need to worry about any of this, because just as you've got these people tracking asteroids and predicting them, and they can predict these asteroids very exactly. And if they ever find an asteroid that is headed for us, however small it is, if it is a fireball, we've already had 4 predictions of fireballs. Even if it's just a few meters across, they will tell everyone about it. But those didn't hit the news because only astronomers are really interested in those, and people are keen on watching fireballs, and they got that news. But if there was a big enough asteroid, then it would be on the mainstream news. And even if it's a splosh in the ocean, then there will be all the astronomers talking, learned astronomers telling you about this splosh and telling you how you can, and then there will be people offer you chartered flights to go and see it from the air. And that is by far the most likely. And maybe 90% or something. It's 99% certain that the next asteroid doesn't hit an urban area. It could be something like Chelyabinsk, where it blows out windows over a largish area, and so you'd have a warning and say watch out for flying glass. That's somewhat more likely. But even that it obviously has happened, so it can happen. But even that is not the most likely scenario. The most likely scenario is it's some very remote place in where there's nowhere near any city or any town, and just a remote place in the desert or the forests or grassland or ice caps or the oceans. Anyway, so that's that. Hopefully this has helped you. And just a shout out for our group, Doomsday Debunked, where we help people who are scared of many things. If you are good at fact checking stories like this, then that's if any of you are decent in astronomy, we've got quite a few people, amateur astronomers, very knowledgeable amateur astronomers there who've been observing the sky for a long time. Quite a lot of those in the group, and but this is very helpful because we often get questions about astronomy, and also if any of you are good at theoretical astronomy, so like myself, I call myself an armchair astronomer. I don't really do observation. I read up about things and you learn about all the space missions and everything, and look at the photographs taken and so on. And but that's my interest. And so if that's your interest in astronomy, then you can also be very helpful, because we get people coming and asking, there's a galaxy, is this galaxy going to harm us? Is this black hole in a galaxy a million light years away, is that going to harm us? And so for the average person who doesn't know much about astronomy, then they get keyed up by, is a neutron star going to hit Earth? And if you know anything about astronomy, then you'll know that this is a very ridiculous idea. Or they'll say, will a magnetar hit Earth or harm Earth? Or things, or they will say, is a star going to hit Earth sometime in the next century? And so some of these are very easy questions for someone with basic astronomy to answer, especially, some of those you need to search up and look up, like I had to do for some of those. But some of the other ones, like if someone says, is a star going to hit Earth? Or is a star going to come through our solar system in the next century? Then you just need very basic astronomy to say, well, look, the stars, they travel very, very slowly through the sky compared with the distances between stars. If you look at this night sky this century, we see the same stars in the same pattern as they were several centuries ago. We don't see any difference at all in the photographs taken centuries ago, in the photographs taken decades ago, a century or so ago, and the detailed charts that were actually made centuries ago. They're just not moving. You hardly notice. And So it's obviously impossible, and if a star was going to hit our solar system, they would get brighter and brighter and brighter, come closer and closer, and you'd be seeing that for thousands and thousands and tens of thousands and hundreds of thousands of years. So that's very basic astronomy. And also you get people asking, well, the moon looks funny, and the sun seems to have risen in a different place from when it used to. That was a question quite recently. Someone on YouTube or TikTok, lady on TikTok, and she said that she's noticed that the sun has risen a little bit further, has risen further north, and she thinks this means the sun's going to do something awful to Earth. And this is just something that happens every year. If you're used to astronomy, you know that after the winter solstice, the sun starts rising further north every day. And so that's a very simple question that you can answer. And so if you've got basic understanding of astronomy, and just even 1 or 2 years interest as an amateur astronomer, then you could be very useful. It's like first response to help people who are scared in the group. If you're someone who's just like, in my case, with languages, or like ask me about Latin, I wouldn't have a clue, or even other languages. Like I tried to study Russian when I was at school. I did no level in Russian. I just scraped a pass. I can't remember hardly a word of Russian now. I've just not got that talent for languages. And so there are people who are like that with science and maths, and it just doesn't, it goes into their mind and goes out again. They just can't retain these ideas very easily, and they don't make a clear picture for them. So if you've got a good background in science and maths or in astronomy, then you're very useful in the group, very helpful in the group, because you get so many questions of that sort, and it's often an hour to several hours before someone responds to them, and that means someone's been panicking for several hours waiting for a reply. And so if you do join the group, then do please read the rules at the head of the group. They're pretty straightforward, but it's very important to follow those rules and just get some idea of how they work. And before you post a comment, it's so some things are slightly unintuitive, like it's if you haven't been working with people who get so easily scared. Anyway, and if you're scared, of course, do join the group, and we do have people who can help you and give you answers about this. You'll get an answer within the day for a question like this, but the faster the better.